take a look at the question up on the board. We looked at this a couple days ago, and you've likely reviewed this with Mr. Burney yesterday. So taking a peek here, we've got a question where we have equations in some other form. They are not in y equals mx plus b form. What form are they in? Does anyone know what this is called? When you look at these two guys here, a and b, it's not y equals mx plus b. We call that slope y-intercept form. What form is this one in here, Graham?
Standard form.
Awesome. This is standard form. Anytime you have an equation and you're set equal to 0, like this, that's what we call standard form. Typically there's an x term, a y term, and a constant. However, if your constant is 0, you might not see a number on the left side. Okay? So keeping that in mind, these two guys are in standard form. So my question for you is this. How can I take a question like part A and make it appear or convert it or exchange it to y equals mx plus b form? Because remember, this is going to be a linear relationship, but I can't see any of the information. I don't know what slope is. I don't know what the y-intercept is. So the only way I could graph this would be by using a table of values. And that would be kind of a long and drawn out process. What do you think, Hassan?
Isolate for y.
Awesome. So essentially what we want to do is we want to get that term by itself, the y term by itself. So what do I need to do to make that happen? Now there's more than one way you can do it. What's one thing I can do? Because remember, ultimately I just want to get the other terms to the other side. And it doesn't matter which one you choose first. So what would be one of the steps I could take? Luke?
Subtract 6.
Awesome. He says to subtract 6 on both sides. I like it. So that'll get rid of the number 6. Could I do something else at the same time? What else could I do? What else could I do, Megan? Awesome. So I could ultimately subtract the x term as well at the same time. Okay, now remembering we do have that kind of invisible border going on, just like from our solving equations unit. So the equal sign separates doing the same thing on both sides. Okay, so we're cool with that? What are we left with if we focus just on like terms? So that would be, those guys are like terms. I've got another set of like terms right here. Here's another set of like terms on the other side. And there is only one x term over here, so there's nothing really to add to. But what are we left with? We have a little bit of a delay on the screen, so I know that you guys might not see some of the highlighting yet, but it will catch up, I hope. I hope so. What will we be left with? What do you think, Graham?
Y equals negative x minus 6.
Awesome. So checking this out, we've basically got these two terms have canceled, so our x terms, I'll show you on the board since it's not showing you right now, our 6's and our negative 6 cancel out, and we're left with just y equals negative 6 minus x, or what might be an even better way to write this. And we're really dealing with some nice delay right now. What would be a better way? I have y equals negative 6 minus x going on. What do you think, Adam?
Just y equals negative 6x.
Awesome. Oh, sorry, actually. Close. I said awesome, but I wasn't really listening. Sorry. Here's what we have. It's caught up with us now on the board, guys. Y equals negative 6 minus x. What's another way to write that? I think I know what you meant, but you didn't quite say it. You said y equals negative 6x. But that would be very different than negative 6 minus x. What could I say? Sarah?
Y equals negative x and negative 6.
Awesome. So essentially swapping our two terms, keeping in mind that I want to keep my signs together, and essentially I'm just going to swap them like so. So you're noticing that the sign does stay with each of these terms here, okay? Now why might I think this is a better way or a more appropriate way to write that? Why would this seem like maybe a more appropriate way? However, they are the same, they'll do the same thing. But why is one better than the other?
Because y equals mx plus b is similar to that because the x is
before the b is.
Awesome. So your y equals mx plus b, you're kind of following that same format, right? So what's the m in this case? What is the m in this case? What would that m be? What do you think, Cam? Awesome. -1, thanks, Cam. So our slope's -1 like we saw last unit. And then how about b? What's b equal to? What is b equal to? Hassan? Awesome, -6. Now, my question for you is this. What would I do to graph this thing? So this is all review now from last unit, right? Getting from standard form down to y equals mx plus b form puts us in a situation where we've what we've dealt with last unit. So now what would I do with those two values to graph this thing? What will this thing look like on the graph? Megan?
You could put -6 on the y-axis.
Awesome. So if this is -1, 2, 3, 4, 5, 6, I'm not going to do our scale to save a little time. And then from there, so that's our y-intercept, right? That guy right there. Now what? What would I do? How do I find some more points on this line? Got some sleepers out there. Hassan again, and then we're going to have to go to some new people.
Because you put on the x-axis, put on -1. Because it's when the x is a 1.
Okay, so can you say that one more time?
On the x-axis, you put on -1 because in front of the x is a 1.
So this guy right there? Are we all good with that? We put it, because b is -1, we put it on the x-axis at -1? Ooh, not quite. Not quite. Because that would mean that this guy, the m value, if we do that, that's saying that this is the x-intercept. But we haven't talked about the x-intercept at all. What do you think there, Andrew?
Once you start at B and then go like over -1 and then down.
Ah, I like it. So he's saying go over -1 and then down. Can you be a little more specific? What's our rise and what's our run in this case?
The run is -1 and the rise is -1.
Close. Close. Help him out here. What's -1? What's another way I could write that slope? If I write it over here, what would that be as a fraction? What would that be as a fraction? Jordan? Awesome. So keeping in mind, a negative number has one of the numerator or denominator would be negative, the other is positive. Okay? Because remember, if these both were negative, then it would turn the entire slope positive, right? So we've only got one. So if we approach it this way, we're actually, instead of rising one, we're actually doing what from that point? Going down one. Nicely done. And then over one. So there's another point. If I go down one, over one, down one, over one, down one, over one, we could think the opposite and we could say go over one, up one. So to the left one, up one, and we'll still get that same line, which I will need to move. There we go. Perfect. So there is our line right there, my friends. Okay, so that last part here is kind of a review from last unit. Okay, so taking y equals mx plus b and graphing it, something that we can't just kind of forget about now that it's over because we will need to keep using it. Okay, so similar thing will happen on that part B. In this case, we're not going to graph it. We're not going to look at slope or y-intercept. But what would I do to get it in y equals mx plus b form? What's that guy going to look like in y equals mx plus b form? Remembering we got to get the y term by itself. So what do I need to do? And I'm going to wait for a couple new hands so I can get some new hands going. What do you think, Oscar?
Y equals -2x.
Awesome. Now, how'd you get that? What'd you actually do? I can see it and you can see it, but what if somebody in here doesn't know what you did?
I got rid of it on one side and moved to the other.
Awesome. So you see positive 2x. So he's getting rid of that 2x. And we're left with our y equals -2x. If we have a quick little chat, what's the slope here? What's the slope in this particular case? Anybody new? Somebody new? Mr. Brown.
-2 over 1.
Oh, I like it. Negative 2 over 1, he says. So now he's kind of telling us what the rise and the run is as well by doing that. Nice. So he could say negative 2 over 1. How about our y-intercept? Where does this thing cross the y-axis? Awesome.
At the origin of 0.
Nicely done. It passes at the origin. If it passes at the origin, folks, what can I say about this particular linear relationship? What can I say? Hassan? Nicely done. So I know it does this, or it does this, or it does something like that. Which of those 3 lines could be correct, and which 2 or 3 could not be correct? Which ones could be correct, and which ones could not be correct, and how do you know? What do you think? Eric?
The ones going up, like positive, wouldn't be correct because it's negative 2x.
Love it. Check that out, folks. We got a negative slope going on here, right? So since that guy's negative, I know this thing has to be falling to the right. That's the only guy that could be right, Eric's saying. He's saying the other 2 guys cannot be correct because they're rising to the right. However, if I want to check if it's correct, I'd actually have to pick a point and see whether it falls to and goes over 1. Check it out. If I go start here and I go down 2 and over 1, it's a little less steep than it needs to be, okay? But that's the one that would be most correct out of all 3 of those. Nicely done. I like it, folks. Okay, so for today, let's get ourselves started.